Welcome, everybody, to the American Space Museum. I'm Mark Marquette. So glad you joined us today to stay curious with Gary Allgire, a former NASA structural engineer on Apollo and Shuttle. Hello, Gary.
How you doing, Mark?
Well, always great to have you on, and I know everybody's happy to that you're on whatever you talk about. But today, 55 years ago, this very moment, April 17th, 1970. NASA and everybody that knew about what was going on with Apollo 13 were going,
Yeah.
because the three astronauts were on the recovery ship. Everything worked through reentry miraculously. And many of you know 55 years of talking about the Apollo 13 tank explosion in the command and service module. We're going to hear all about it from Gary Allgire. And Gary did a personal investigation of this, though you weren't part of the official investigation. As a structural engineer on this North American spaceship, there you certainly knew a lot about it.
Well, I was assigned to Apollo 13 mission with Jimmy Handgartner, who was my lead at the time. And so we followed it all the way through to the very end, of course, because of what happened to Apollo 13.
Yeah, well, awesome. And so I'm going to just kind of turn it over to him. I'm going to say thank you all that are watching, our regular members out there. We'll give a little shout out to you, particularly at the end, if you've got a pertinent question during the pause where Gary's talking about. But he's been working on this for a while. He told me he's a snowbird, loves to go up with his wife to Georgia, up there. What part of Georgia?
Northeast corner, which is the mountains.
The mountains, northeast up there.
As we call them mountains. Now, if you live out in Colorado, they call them pimples or something.
Pimples or mountains, yeah. Well,
Yeah.
I'm going up to the mountains of Appalachia for Easter break here and see my family. And but probably the last show Gary does live in our studio, we'll probably bring him in sometime, a couple times in the summer. When we get up to doing Google Meets and stuff like that. So, but we want to thank everybody for supporting us through Shuttle Fest and other events that we do. So we got Mitch Rothman on there, Carlton Bailey, hi to you. My daughter, we always get so much info from Gary. There's my daughter Jessie and grandbabies McKinley and Macy watching. Gary Gerald says good afternoon. He's up there in Collins, Georgia. Doug Forrest says hello. Mark Thell says hi, Mark and Gary. And hope you got to meet Gary, Mark, if you didn't. And Tommy Usacks, nice to see you last weekend, Gary, Tommy says. And can't forget Marty. No, we can't forget Marty there. And Dave Stangy's got an early question. What was the cause of the early shutdown of the second stage center engine?
That's what I'm going to talk about in a few minutes here.
Okay.
We'll cover that issue of why the engine number 5, which was the center engine on the second stage, shut down early.
And he also wants to know as you go along, and I'm sure you talk about, why were they in blackout longer than expected on their return?
I'll talk about that too.
All right. So Dave Stangy, thank you. We're going to kick it off with Gary here. But 55 years ago, Gary, I mean, being a teenager back then, you were living it. As a few years older than me, but not much. And the drama, the day-to-day drama, without the social media, 3 TV networks, it was something else. The radio, I always say, what was the Twitter or X of the day in the 60s and 70s? Well, that was AM radio, because the top and the bottom of the hour is when they always did news.
Okay.
So I remember it vividly, and everybody was just puckered up listening to that reentry coming in. So Gary, set it up for us. I've set it up for you, so take it away.
Okay, well, we need to go to the next slide because we're going to talk about, let's go one more. Okay, I have highlighted 5 of the missions prior to Apollo 13. It's Apollo 1, and we have Apollo 6, Apollo 8, Apollo 9, and Apollo 10. If it wasn't for those missions, we would probably not have had a good, successful return of Apollo 13. They all contributed to something for the that particular mission. It's Apollo 1, believe it or not. It's because of the fire. NASA went back in there and went through all the wiring. What they did is they took one of the Block 1 vehicles that had not flown yet and totally took it apart and went through and analyzed all the wiring to see if they could improve it, in which they did, because it came very important, because when they got ready to go back into the command module and to power it up, there was a lot of concern about whether it would work because of the cold soaking of the vehicle it had gone through. And because of what they did in Apollo 1 and improved all the connections and all the wiring, that they would successfully were able to power up the spacecraft.
Essentially made them waterproof.
Well, not waterproof, but they made them a lot better. Yeah.
Okay.
Yeah. Now, I was curious to find this out. Do you know how many feet of wiring was in the Apollo spacecraft and the command module? Service
How
module?
many feet of wiring in the Apollo Command Service Module? No, but we need to get back to Marty's question of the day, because that'll be a good one. How many?
It was 110,500 feet of wiring, which is 21 miles.
Wow.
There's 30,000 separate segments that make up that number, and there's 60,000 connections that are in that vehicle.
16,000?
60,000.
60,000.
Yes, between crimping and then soldering. They preferred crimping because it was actually worked better for this environment than the soldering did.
Huh.
And then for the lunar module, they had 75,000 feet of wiring, and which was 14.2 miles of wiring, and they had 20,000 separate segments that make up this wiring harnesses with 40,000 connections.
40, and Marty Winkle, our co-producer here on Stay Curious 5 years, worked with all those connections, or some of them, we'll say, right, Marty?
Definitely not that many.
Definitely not that many. Okay.
The actual weight of the wiring in the command module was 1,330 pounds.
When I hear these stats, Gary, I think about people bringing this stuff in. You know,
Well,
the bundles of wires is
Yeah.
brought in and so forth.
They're put together on we call a shadow board, where they had the wiring harnesses laid out, and they would put them in there, and then they tie them together, and then they take those up in segments, and they bring them into the spacecraft, and then that's where they put them, and they reroute them. Of course, they have the inner shell and the outer shell are separate, so they have plenty of area to work with back in those days. And the lunar module weighed wire harnesses weighed 460 pounds. They used a little bit thinner gauge wire on the lunar module. Except for the panels, they had to go back and redo those because they moved the panels in and out so many times because of, I guess, issues that they were breaking the wires. So they increased the size of them just a little bit. Then Apollo 8, which is what I'm going to answer his question, is that Apollo 8 was important to the mission because they had a pogo effect that really was detrimental to the vehicle to some extent. So
You're
they
talking about 6.
Not 6, rather. I'm sorry, 6. And what they did is they went back and rewrote the programs for the software. And so on Apollo 13, engine number 5 starting to experience pogo oscillations. They were minor at the beginning, but each separate next one that happened was increased in velocity. And so what they did is they had it set up so if it got to the point where the engine was going to self-destruct, then they would shut it down. And that's what they had to do. I think it was on the 4th cycle. The 5th cycle would have been a catastrophic explosion of the engine, which would have caused for an abort.
My gosh, I didn't hear about that close.
Yeah, and because of that, also the 4 engines had to run a little bit longer because they had more fuel to work with, and so they actually shut down 2 minutes a little bit later once it went to get into orbit. And finally, when they used the S4B for the final to get into orbit, they were actually about 10 miles short of the actual orbit that they wanted to get into. It was 90 versus 100 miles. And then Apollo 8, which is interesting about this one, is Jim Lovell practiced this guidance system when they were going to the moon, if they had a failure with all the guidance system, where they would use the COAS and to line the vertical line on the center of the Earth and use the horizontal line to line up with the horns of the Earth, and that would give them the proper orientation for them to fire the engines to get them back to Earth. He didn't think he would ever use that, but he had to use that on Apollo 8.
Hmm.
And then Apollo 9 was when we flew the LIM, but we didn't go out. We stayed in orbit, and that's when they used the descent engine on the lunar module to, when they were docked to the command service module, fired that engine to raise the orbit up, and then they brought it back down. So that gave them the confidence to be able to fire the descent engine to take them from the non-free return trajectory to put them back onto the free return. And then Apollo 10 is interesting in this respect, even though in a roundabout way, it's the cause of Apollo 13's problems. But they had developed in the back room under Honeycutt, these guys had developed a program to figure out how to use the lunar module batteries to charge the command module batteries, which was a very important thing that they had to do during the mission on Apollo 13. The other thing that they did, and this is kind of a surprise to me, is that's when they developed the idea of how to convert the canisters from the command module to adapt to the canisters in the lunar module.
The carbon dioxide
Yes.
scrubbing canisters.
Yeah, it's always been published that it was at 13 when they did this, but they actually had come up with the idea, and they came up with a fix to do that. Now, that's the thing that I've saw an interview with a gentleman that says that happens.
You're talking about the sim operators came
Yeah.
up with that in
Yeah.
Houston, and Jay Honeycutt was one of the lead sim operators there.
Yeah.
Very interesting.
And the last problem that they came up with that they had to overcome, which is kind of minor, but when they separated the command module from the lunar module prior to re-entry, they did not have the capability to do a translation to back away from the lunar module because nobody's in it. It's unmanned. It's not powered up as much. So what they ended up doing, because the command module does not have at this time the capability to do translation movers back and forth, up and down, side to side, because that's all tied into the service module RCS engines. So all they have is roll, pitch, and yaw engines on the command module. So what they had to depend on is what they learned in Apollo 10 is the air pressure that's trapped between the 5 psi that's trapped between the two tunnel hatches. Okay, that pressure will help push them apart, plus whatever the little bit of motion they get from separation that's firing the ring off. So, because they didn't calculate that for Apollo 10, and that caused Apollo 10's lunar module to go into a sun synchronization orbit because of that, and that was never planned for that.
Uh-huh. So a
So
lot of serendipity discoveries there.
so if they hadn't already had experienced this stuff, we may have not have gotten them back safely.
Wow.
Especially with the charging of the batteries in the command module, because they have 3 batteries in there we'll talk about, and they all have to be topped off for re-entry. And they did use one of the batteries during the mission. So if they had not done that, then they may have not made it back in.
No energy to do the pyros for the parachutes.
Well,
or stuff like
it's
that,
everything
maybe.
to keep them alive, keep the spacecraft powered up.
Yeah.
That's the only power that they had.
All right. Let's get into this.
Okay, next I'm going to go back a little history about Apollo 10, and there's another little strange thing about this. I did not work Apollo 10. The engineers in our office the lead was Bill Beaker, and John Link was his helper on there. And they got the word from JSC that we needed to remove the cryo shelf, which was the O2 tanks, and send them back to the blue one, to send them back to California for a modification. And so in the process of taking that out, we can go to the next slide. Go forward. This is the piece of GSC equipment that we would use to remove it. I think we've talked about
GSC.
ground support equipment.
Thank you, sir.
Okay, it's a sling. It has the capability to remove. It has three configurations that you use. It's just one unit, but three configurations, and we can take out the fuel cells. We could take out the hydrogen tanks, or we could take out the cryo tanks. And what we're in the process of doing for this is, while we're in the chamber, we're going to pull out the cryo tanks, and we're going to send that shelf with the tanks back to down to California for whatever modification they were going to do. And so, but they ended up sending us a brand new set of tanks, a shelf. So we put that in. So let's go to the next slide. In the slide here, this is a side view of the sling and the tanks. And I put in little dots. Those represents the rivets that had to be removed.
The blue dots.
The blue dots. There's a series of them on each side of the walls. Those had to be removed. And then what they forgot to do or did not recognize they had to do, I highlighted in yellow up there. It was a single bolt, and they didn't undo that bolt. So when they tried to lift the shelf out, they put so much pressure trying to do that where the X is on the sling, it snapped that piece of equipment in half, or made it break in half a little bit. And so it caused the shelf to pitch up. And the oxygen tank 2 is the one on the right. It hit the fuel cell shelf above it.
Okay.
Okay. We removed it, and when we removed it, we would have written 2 discrepancy reports. One on the shelf saying it had possibly been damaged, and 2 on the tank possibly had been damaged. The discrepancy report on the tank should have went back to California for them to investigate. We would have pulled blankets back and looked at the area, and if there was a dent, we would have repaired it. Okay.
Mm-hmm.
Now, down there is an arrow. On top of the tank is called the closeout cap. That is what hit the shelf. Now, what's
At the very
no,
top.
come back down. There's an arrow.
Oh, right there. I see the yellow arrow.
Yellow arrow right there. And so this shelf went back, and we put the new shelf in and closed it up, and that was into that. But we also heard, and I couldn't say it was a rumor or not, is that also at Downey they had taken an Apollo 10 shelf. They had pulled it out too for a modification. They had a problem with a electrical magnetic interference with some of the pumps, so they had to take it out to fix that. Now they also, according to the accident investigation, when they pulled it out, they also forgot to take the bolt out, and it did the same exact thing. It hit the shelf too. So Apollo 10's shelf, if you look at the records, which is not very clear, that shelf was removed twice for that flight. And then the one that they broke, damaged, it was put into Apollo 13s.
Wow.
Okay. And they didn't x-ray it, obviously, but they did check it out, and it's passed their testing that they did. So it came to from California to Florida, which was SM 109. 106 was Apollo 10, and that's the one that possibly had 2 different shelves put into it during its flow.
And you know all this by the piles of paperwork that followed all this, correct?
Well, I wish I could say I reviewed it, but no.
Oh.
This is just looking through an accident report after the investigation. They put out a pretty good report. And they talked about in there, they never mentioned the one that we did here at Kennedy Space Center. All they talk about is what happened at Palmdale.
Okay.
Not Palmdale, but Downey, California. So that was that's kind of a strange thing. And what surprises me is their engineers did not talk to our engineers here at Kennedy to let them know about the bolt. So it actually happened twice.
And we're going to hear about Apollo 13 from Gary Allgire here. I see my daughter Jessie asked a question that I'll take on at the end of closer to the end of our program here. So go ahead and continue, Gary.
Okay. Now this is, I believe, if I was this picture was taken down in California. This is when they had their problem, and what they have done is they have a picture here with the tank. There is no insulation in the bay, and above the where we call the horn or the closeout horn is up there is a certain little white circle that was dented, and they came back in and repaired it by putting a plate over it. So this is just shows how close they were to the fuel cell shelf. Now this is going to go through a little bit of the construction of the tank. The tank is actually made up of three pieces. There's an inner shell, and then there's an outer shell, and there's both of those shells are made of Inconel. In between those two shells is they put a insulation that you see, which is the tan insulation that you see there for to keep the tank at the right proper temperature. This
Holy moly!
Yeah, this is a little complicated. On the top is oxygen tank number 2. The blue lines are showing you how they would put the fluid, the supercritical oxygen into the tank. The long pole coming down is the fill line, and then to the left of that, just up at the top, you'll see a shorter one. That is the vent line, and then to the right of that long tube, you'll see a filter. And then from the filter, you'll see a line come out. Instead of going directly to the fuel cell, it actually goes into the installation between the two shells, and it goes and wraps around almost completely around the tank before it comes back out and goes to the fuel cells. I don't know why they do that, but that's just the way it was laid out. Okay. And fuel cell number cryo tank number 2, you can trace the lines where it feeds the fuel cells 1 and 3, and fuel cell number 1 feeds the, which is in yellow, feeds the
tanks around on the left, on the fuel cells where it's going is over here.
Yeah, the blue, the blocks over there represent the fuel cells, and that's the yellow one. It would be fuel cell number 2.
Mm-hmm.
This is what it looks like inside that tank a little bit better. You have your fan motors. You have 2 vertical tubes. The one on the right contains the fan motors. There's one at the top and one at the bottom. And you see this looks like cross wires. That is the heater element. Okay. And then on to the left one is the capacitance that measures the quantity of the fuel the oxygen in the tank, and it actually comes in through the line and goes down through that tube, and it fills the tank up. And as it comes out and goes out to the fuel cells, you can see where it breaks off, it says to the fuel cells, and if you go down further, it's buried at the bottom of the picture there. There's a pressure relief valve that relieves at 1,000 psi. Can we slide the thing up a little bit so I can see the top of the tank?
Oh, I'll have to do it like this, small.
Okay. Up there is the closeout cap, and then there is also a blowout plug. That blowout plug is activated at 75 psi. Okay.
Let me try it.
There you go.
Thank you, Marty.
Now the wiring is put in through that cap over on the right-hand side. That was one of the things they found in the investigation, that it was a blind feed, and there was sharp objects, and so they physically could have damaged wiring during the manufacturing process. But this is not what we think caused the problem. Okay, this is the feed line coming into the capacitor that you see there, and to the right is the filter where the liquid, the oxygen would come up through the filter. It's supercritical oxygen, so that they can get more into that tank than they can normally. It's not considered not a gas, and it's not considered a solid.
Huh.
You know what that, did a little search on that, and what they do is you have these oxygen modules kind of floating around. They take that all out and they just put it's all just oxygen atoms. It's all it is. And so they have to keep it at a certain pressure so that they don't stick to each other. And why they have the fans is to keep it circulated so they don't have a glob of them come out to go to the fuel cell and then not have anything. They want a constant flow of oxygen to the fuel cells. this is what they think happened when they hit the tank. The tank hit the fuel cell shelf. It knocked loose the connector between the top of the dome to that capacitor device right there. And so you go to the next slide. I guess this is a little bit early. We can see if we can go to another one here real quick. What happened was when we got the notice, when I came into work one day, we had just finished countdown demonstration test, and walked in the office, and Jim set me down and says, "Hey, we have a problem." He says, "It looks like we're going to have to remove the tank," which means we're going to have to remove the shelf because they couldn't detank the oxygen in that tank. They're supposed to drop them down to 50%. And they sit there, and then they come back and fill them back up for launch. Well, tank number 2 only drained as 97%, because what happens is they try to put air pressure into the line and pressurize it and force it out through the vent system. But because it had been dislodged, they couldn't get a good pressure to do that. So instead, what they, as a workaround, which kept us from taking the tank out, was to turn on the heater and run the heater and have it build up the heat to pressurize to have force the liquid oxygen out of the tank. Now, the tank, when we're flying in orbit, we use 24 volts DC is what the heater takes. That's what it uses for. But at the pad, we can't do 24 volts, so the ground system provides 65 volts. Now, Beech Aircraft was the manufacturer of the tank. They contacted them and says, "Hey, can we do 65 volts to heat this thing to get the tank to get detanked?" And they said, yes, there'd be no problem. It would handle that. What they didn't ask was, what about the rheostat? The rheostat connectors, which open and close to turn the heater on and off. Okay, well, they couldn't take the 65 volts. So when they're running this thing at 65 volts, the first time they tried to come open to turn it off, because it was getting to the cutoff temperature is 85 degrees for the tank. The instrumentation in the firing room only goes to 85 degrees. So when they hit the 65 volts, the 65 volts to the contacts, they welded shut. So the heater never turned off. It was on for 8 hours. They estimated that the temperature in the tank got to 800 degrees Fahrenheit.
800 degrees, wow.
And what happens is the wiring is in Teflon coating sleeve, and the Teflon kind of just dissipated a little bit and melted away, and it didn't catch on fire, but it did melt away and expose the wires. So this is what caused the spark that generated the problem that they saw on Apollo 13.
I'm fascinated, and I know you are. There's the cause of it right there.
Yes, and they did prove that. They went back after the mission, and they went and did this. This is, if you look at it on the mission itself, what happened was when the wires crossed over, the wiring with the little bit of insulation hose on it ignited, and it worked its way up into the above area where the filter is. Now, they calculated that the amount of energy in that piece of material right there was about the equivalent to a candy wrapper. It would not have caused the issue that they did. But the filter is a culprit. It is compacted with stainless steel pieces of stainless steel, and that caught on fire, and that provided all the energy it needed to do two things. One is it did not blow the tank apart. Okay, the tank was designed to hold 1,000 psi. We normally fly with a 1.4 safety margin of safety, which means the tank actually could handle up to 1,400 pounds. I did find out through records that they actually, I think they broke one. It bursted at 2,200 pounds. But what happened before that is that 1,000 psi pressure relief valve opened up, and also the cap would come off at 75%. So if we go to the next slide, I think we can see what the results are. This is actually what they did. They went ahead and did the what happened on 13 reconstruction, and so it blew out. And now they say it was a possibility they could have blown the dome off, but what ended up was they figured out they did this also in a test. Is it if they pressurized that compartment to 25 psi, it would blow the side panel off, and they did demonstrate that. Okay, so when the panel came off, on the mission, it came off. It hit one of the antennas of the 4 antennas that make up of the high gain antenna, and so it caused a lot of motion in the vehicle. And so, but that's what really happened, and it also lifted up the fuel cell shelf up a little bit. And again, so we'll talk about that as we go along, what the results of that was. But they did redemonstrate the issue, and I think the next let's go back a couple slides real quick if we can. Go back one more. There we go. This is the fan motors, and they cut away a tank after they heated it up for all that time, and you can see the wires, how loose they are and how bare they are.
Did they heat it up to 800 degrees?
I'm sure they did.
Wow.
And then just do it. Now for the fix, they took the fans out, and they also put the wiring into stainless steel casings, and so that they wouldn't have that problem again. They also doubled up the number of wires on the heater.
Okay.
Okay. Now, when we did at Kennedy, when we found out that we had passed we got the fluid down to the 50% that they would need it, then I went in the next day and Jim said again, we got to pull the tank. I said, what for now? He says, well, now, he says the tank quantity sensor was no longer working. So we're going to have to pull it for that. And then a day later, they came back, oh, we got a fix for that. And the fix was to cycle the fans once every 24 hours. Okay.
Okay.
Now, Andrew talking, when he did his pitch, said it was the 5th, but it's not. I'll get to that one in a minute.
And we're going to look at this chart here.
Yeah, this is a chart here. Let me see if I can get this thing right here. We've gone through that. Now, we do a mid-course correction at item number.
Launch is number 1 at the bottom.
Yeah.
Then you got your engine to get it into orbit.
And
Translunar injection.
Yeah.
Maneuver there, number 3. Then we go to 4. Service module separation, command module.
And then we do a docking.
Docking.
And then we disconnect and take the lunar module out, and then we turn around and head to the moon. And on the day, about 1.5 days into the mission, which is number 5, that's when we do a mid-course correction to take us off the free trajectory that we're going to.
Yeah, 6 is the mid-course correction right there.
Yeah, 6. I'm sorry, I got the wrong number. That's 1.5 days later is when we do the mid-course correction, and that's gets us off the free return trajectory and puts us in a position to land. Is it Fran Moro, I think is where they were going to land.
Yes.
And also, as part of that, the third stage, the S4B, was designed or intended to impact as close to the landing site of Apollo 12 as they could get. And this is the only time Jim Lovell said, hey, we did have at least one successful thing. It crashed into the moon 25 miles from the landing site of Apollo 12.
To pick up the seismometer.
Seismometer from the LSEP.
Yeah.
Okay. Now, everything was good and fine until we get to 7, which is when the thing that really happened here. This is when we have the loud bang and the loss of the DC bus main B under voltage. There's a gentleman in the back room. You have Jack Lausma, who is the Capcom. You have Gene Krantz, who is flight. And then in the back room is a gentleman that has a call sign of Econ, and it's EENOCON. He's electrical, environmental, and consumables. He's monitoring the cryo tanks, and he noticed that he was getting an erroneous sensor reading on one of the cryo tanks. So he requested through Gene Kranz to tell the crew to turn on the cryo tank fans so he could get a reading. Okay. And a minute and 54 seconds after he turned those fans on is when we had the venting of the tank. I'll call it, I'm not going to call it an explosion because it did not explode. Okay. The rapid venting of the tank. And that's happened 1 minute and 54 seconds after that. And that's when all hell broke loose for the crew, really.
But it blew the panel out from the
blew the
venting,
panel.
and maybe the top of the tank.
Yeah, top of the tank, but it blew the panel out.
More like a tea kettle lid or something.
Yeah,
that
it's
pops
welded
off,
on, but it
hit
hit the shelf probably. If it came off, it hit the shelf. If nothing else, the blowout plug would hit the shelf, and the pressure also would have probably have caused it to buckle a little bit. Also, I found out there's this possibility that the tunnel wall was compromised also.
Hey, Gary, was the fan running that entire time? The 1 minute and 57 seconds?
Yeah. It took that long for the pressure to build up, is what they're saying. From the time he turned the fans on to it actually.
So if the tank had the damage we've seen, we'll see here in a few minutes. But so if the tank had exploded, there'd have been a lot more damage.
Oh, it would be a lot more damage. They would have probably punctured the other tank, and it could have. I mean, it would have been a lot.
Yeah, it'd have been.
That's a lot of energy
right.
that's in there.
Taking the engine out, maybe, and all this.
Well, the engine still may have been taken out. I'll talk about.
Okay.
And so now, what's important thing here is Jim Lovell said at that time he had to make a decision. He could have. I don't know if it was the engine on the service module or he was going to use the lunar module engine. They can do an about turn and come back straight back.
Really?
Yeah. They practice that.
Kill that momentum going to the moon. 3 days they'd slowed down from to maybe 5,000 or 6,000 miles an hour.
Yeah, they slow down as there's a point where they start slowing down because the Earth gravity is pulling it back.
Right. Yeah.
The moon gravity grabs them and pull it towards them. So there's a point where it's the slowest, and they'll start picking up speed again as they get closer.
And actually just thrown it in reverse, so to speak.
They're throwing it in reverse. He says it's a very critical one. It's you get it one shot, and if you get it wrong, you're not going to ever see the Earth again.
Right.
So he decided not to do that.
Okay.
Okay.
How many did he have an hour to decide that?
No, he had to do it. I think he had to do it pretty quickly because they were losing power in the command module. Immediately when that happened, Gene Kranz started ordering the crew to start powering down things. They were trying to get a goal of getting down to 10 amps of usage. The best they got was 11 amps, but 10 amps is what they wanted to get to. So to protect the batteries, because they cannot use the batteries in the command module. Those are dedicated for re-entry only. So what they have to rely on is the batteries that are in the descent and ascent stage of the lunar module.
So also, if they'd not had the course correction, this had happened before the course correction, they were on a free trajectory. It would have made it back quicker.
They would have probably made it back fine. I don't know what the time frame is. It's 8 days. It's 6 days, 3 days to the moon, 3 days back. So they would have made it back in 6 days.
Okay.
Which is close to what they actually did.
And there you see the looping around the moon, and they had to do a translunar injection with the lunar module engine, not the command module engine, and then do a third course correction. That Jim Lovell, who is 97 years old and probably telling about this where he lives, had to use a sextant and everything to do it.
Well, what we're going to do is we're going to go to item number 7, which was the tank issue. And then there's a lot going on.
There's a 7, okay.
What the econ engineer, Cy Levernaut, he was trying to understand what happened. And so all he knew is he had undervoltage on bus B, and he could not look into the sensors that were on tank or cryo tank 2. And he kept asking Gene Kranz, can you give me 5 amps so I can look at this thing? and twice he refused to let them do that because he's concerned about keeping the crew alive and keeping the spacecraft alive. So he does not want to waste precious voltage for this thing. It wasn't until Glenn Looney came on board that he finally gave him the permission, but they had to do something else before that could happen. But they were looking at powering everything down. They're trying to understand what was happening. And all of a sudden, they start seeing that the oxygen tank number 1 is losing pressure. It's losing its pressure. So again, they asked, can you give me 5 amps so I can turn on the heater so I can see if the heat causes the pressure to come up. And eventually they did get that, and the pressures did not come up. And that's when they told the crew, get into your lifeboat, which is a lunar module. Because, and then they actually had Glenn Looney, or Gene Kranz later on when he came back, asked him how much time do we have? And after this was about 45 minutes into the situation, and they said you have 1 hour and 54 minutes before the oxygen tank number 1 goes dead, and then you have no more power coming from the command module.
What was causing O21 to leak?
Well, probably because they lifted the shelf up. They never did trace it. They tried to do some isolation. They thought maybe it was coming from since they're kind of manifold, the 2 oxygen tanks can be manifold together. They thought maybe there was a leakage in that line between that part. And so they tried to isolate it. Nothing changed. So they never really identified it. But after the crew, when they separated from the service module and did a visual, that's when they said, hey, the cryo tank, the fuel cell shelf has been tilted up. So it probably in there, they disturbed some lines.
All right. Fascinating conversation here with Gary Allgire, structural engineer for NASA, 33 years. And he's providing another great show today, Gary.
Okay. Now we got to make some more decisions here besides just powering down as much as they can. The next decision they're going to have to make is once they realize they're on this new back on the free return, but that free return was going to bring them back in, and they would land in the Indian Ocean. And it was I forget how many days it was, but it was doable. But the problem was the Navy did not have any resources in the Indian Ocean. So they would be in the ocean for many days before they could get somebody there to rescue them.
Is that right? Huh.
So they had to make a decision. They could use, they could use the descent engines and change that to where they wanted to land in the South Pacific, or they could land still in the Indian Ocean, but they could come in 36 hours earlier if they used all the fuel in the descent engine, descent of the lunar module, plus ejected the service module off, then they could come back 36 hours early. In the India, and they said, no, we're not doing that. So what they decided to do was we'll go into and land in the Pacific, and we will come in 9 to 12 hours earlier than planned. So that's what they did. So this is what they did as soon as they passed the moon. When they got to the closest point to the moon's surface is when they did this maneuver, and that's maneuver number 9. It was a 4-minute, and let me see how many seconds burn that was. It was a very critical burn. And again, the problem, I should have talked about this a little bit earlier. The first, to get back on the free return, they had to transfer the IMU measurements, which is the initial IMU, inertial measurement unit. They had to transfer those coordinates up into the lunar module IMU. And to do that, Jim Lovell had to make some calculations to make some corrections for that maneuver. And he did it by hand or by mind, I'm not sure which. And he did his measurements, and he contacted JSC and says, would you verify my measurements before we do this? And they came back and said, you were right on. So he transferred those up there, and that's when they did the burn with using the IMU and the guidance system on the lunar module. Now for the second one they come through, they can't use the full up guidance system on the limb, so they use the backup system. And as part of the backup system, he had to have a star reading. And because of all the particles that were floating around with them from the tank venting and all the mylar breaking up into space, he couldn't do a star sighting. So they told him to use the one star you can see, which is the sun. So he was told to put the sun in the middle of the lunar module's commander's window, and that would point that. And I think he had to point something at the moon. And if he did that, then he could use the engine and fire it, and they would bring him back. Now, it was a 4-minute and I think 23-second burn that was done correctly, and that put him back into landing into the Pacific Ocean.
So Lovell probably used the hash marks for distances in that triangular lunar window to line up the sun in a certain place,
Yeah.
and then in the docking hatch.
Well, the overhead window that he had was which was about like this. It had marks on it. He probably lined that up to a certain way.
Right.
So that's what he had to do. So let's go on to the next one. There's been a bit of question between Marty and I. Well, we were talking about this before we came on with this program a couple of weeks ago. Is how did we get power from the lunar module to the command module? And he didn't remember, and I didn't remember. I sort of remember. We had connectors. It was in the tunnel that we would hook into the lunar module, so we'd have a power connection between the two vehicles. And this points that out that there is. It's highlighted in yellow. You'll see it says up there that that's the connections where it's in the tunnel itself, where we would take cables from the command module and hook it into the lunar module to provide electrical continuity between the two vehicles. And over in the back, on the back wall of the lunar module, we had two battery or four batteries? Two batteries that were being used, and then we had another 4 batteries down in the descent stage.
Here, okay.
And we'll see those a little bit later. And after they undocked from the S4B, this is coming before they actually were on the way to the moon. This just shows the vehicle, what it looks like with nothing in it. And this is the 3 fuel cells. Fuel cells 1 and 3 use cryo tanks number 2. Fuel cell 2 use cryo tanks number 1. If you want to know about the hydrogen tanks, it was never mentioned in this episode. Fuel cells 1 and 3 use fuel cell tank number 1, and then fuel cell number 2 use hydrogen tank number 2. That's how they separated those out. And this is a schematic that shows you how these fuel cells were connected to the buses. Fuel cells 1 was connected to DC bus main A, which is the green, up at the top.
Yeah.
And at the bottom is fuel cell number 3. It's connected to DC bus B that you see down at the bottom. Fuel cell number 2 can be configured to operate both, either go onto bus A or bus B. For the missions, they put fuel cell number 2 onto bus number A, the DC bus A, okay? And then the yellow ones are the inverters. Now, the fuel cells can produce 27 volts DC up to 41 volts DC at the max. We use a DC and AC circuits in the command module, just like we do in a camper. If you have an RV, that's used the same type of configuration. So we have 3 inverters that are located in the command module. Now, and converter number 1 is tied into a DC bus A, and it gets us 28 volts from bus. And it takes that and converts it into 115 volts, 400 hertz, 3-phase electrical power, AC power. And that goes to your AC1 bus. Okay. And so fuel cell number 3 goes to bus B, and it goes, the output from there, it gets 28 volts to inverter number 3, which is the bottom of the, that's number 3, okay? Okay, and number 2, the inverter number 2 is just sitting there, and it can be programmed to go either to either A or B buses, okay? So this is the configuration prior to what happened. Go to the next slide. Okay, now we've had the incident. Fuel cell 3 and fuel cell 1 go down. They're not providing any 24 volts to the buses. So bus B, which is getting its voltage from the fuel cell number 3, it goes and shows an under voltage caution warning on the panel. However, fuel cell number 2 is tied into bus A, and because it's tied in, it stays up. And so it kind of gives you a little bit of a false indication there. And so the inverter stays up because it's getting its voltage from the bus. And so this is the configuration that they were looking at. And they start realizing that eventually cryo tank number 1, which is providing oxygen to fuel cell number 2, is going to go bad. And so there's a rush to do as much as we can while the vehicle is still powered up. And eventually they get down to the point where they're going to run out of power before they complete what they have to do. And so what they made this critical decision and told, Gene Kranz told the crew to go ahead and put battery number A of the 3 batteries that are in the command module online so that we can keep the power up so we can complete our power downs. It takes normally 5 hours to power up the lunar module. And what they did is we did an emergency power down, and that did it in 90 minutes. And the same thing.
Okay.
And one thing I do want to point out, there's a lot of emphasis by the crew and by the news media about Ken Mattingly, because he was pulled from the crew 2 days before the launch. And so he, when this happened, he went into the command module simulator to do all these switch configurations before they even passed it on to the crew. Now, the person who went into the lunar module was Ed Mitchell, who was the Apollo 14, had been on Apollo 13, but it was Apollo 14 lunar pilot. And he does not get any credit, but he was very, very important in doing what his had to do. And so I'd like to call him out because he's never been called out normally in any other.
Ed Mitchell walked on the moon, of course, with Al Shepard,
Yeah.
follow up of this mission of Frau Merrill, great friend of the American Space
Yes, he
Museum,
was,
did
yeah.
a lot of fundraising and so forth back in the day. I'd love to have met him.
I did meet him.
You did meet him.
I did meet him and talk to him, and then he was very kind to allow he'd have my picture made with him and didn't charge me.
Yeah. Did you say that he was an unsung hero of Apollo 14 or 13?
I do. I think especially when I started looking at this stuff and didn't realize what he had done, and he never got the recognition that Ken Mattingly did. And Ken Mattingly really lucked out because he did get to fly and go to the moon.
Yes, he did on 16.
16.
Of course, Jack Schweikert was the one that replaced him because he was exposed to measles.
And I want to
never got the measles either.
I listened to a lot of the communications for this presentation. Jack Losman was the hero for me.
Really?
Yes, he was so calm. He did all the communication basically between Jack Losma and Jack himself, and he is so calm and he's just so professional. And he's got a real wicked sense of humor. If you listen to post-mission interviews, yeah, he's a cool character. He was the right person at the right time, really, to be put there. I don't want to discredit Ken Mattingly, but Jack really pulled his weight as a backup crew.
Yeah, Jack knew he had to keep his voice. He had to come across very calm.
Yeah,
he didn't want to excite.
I think that's he was normal. He was the only bachelor.
Okay.
On the mission, and when the press talked to them at their press conference after the mission, asked about their wives and how concerned they were. And he said, well, they were concerned. And he said Jack Schweikers, all his girlfriend, all the airline stewardesses were kind of concerned of him because I guess he tried to date all the airline stewardesses. He was single.
Well, you got to see Jack Schweikert a year ago, November, here
Yeah.
at the American Space Museum with Rusty Schweikert when we celebrated Skylab. Marty's always had him at the Apollo Grumman reunions in there, so I certainly have had a couple meals with him. And he's 89 years old, born on Leap Day, but he's 89. And you know what? We hope to bring Jack to Shuttle Fest 5, folks.
Oh, I'll have to be.
We're going to try to effort that and give him a little last hurrah.
Well, I was very, very impressed. Jim Level did ask a question later on. I'll talk about that. There was some little bit of concern in his voice. He wasn't very manly, not manly, but that's the wrong set of words to do. But he was a little concerned, and whereas Jack never displayed that.
Mm-hmm. Very cool. We got one quick question here from Mark Thel. Did they eliminate tanksters for the rest of the missions?
Tanksters.
During the oxygen tank in there.
Well, starting with 14, yes, they did away with that. They found out that we could get the information from the tank quantity without using the fans. So they did take the fans out. They added an extra third cryo tank in one of the other bays that didn't have the room. They added a 400 amp hour battery to the service module to back up fuel cell number 2. And then they made some mods to the lunar module. They put the swash baffles in the lunar module descent tanks so that they didn't get the false reading that they were running out of fuel. They went from Teflon to stainless steel sleeves. And what's interesting about Teflon is considered a fire retardant. It's used in the race cars. Their fire suits that they use or firemen use, it has it in there. The Apollo couches had Teflon impregnated beta cloth because of that capability. But Teflon, which if you may not know, is considered a self-extinguishing material. So if you take Teflon right here in this room and you put a match to it, it will start to burn. As soon as you take the match away, it will go out. However, what they had not realized, at 800 psi or 1,000 psi, it will burn and stay burning. Mm-hmm. So that is one of the reasons why the fire continued on into the dome area. Let's see. Eventually, they were smart enough to go ahead and put, as long as they had power off of main bus A rather, they went ahead and switched over so that fuel inverter number 1 would also work on giving power to the AC bus 1. And so this is when Cy Leeuwenhoek found out that the tanks were in trouble. They had blown one, and then the cryo tank was going to go dead, and that's when they decided to go into the lunar module. Now, when they went in there, as soon as they had that, the first thing that Jack Schweikert did was started transferring water from the lunar module into the command module, or from the command module, into the lunar module, because they're going to lose water capability to get it out because they don't have power. So he started filling up bags to put it in there. And somehow, during this part of it, he got his feet wet. I don't know why, but he got his feet wet because they noticed that during the days when they were coming back, the temperatures dropped down to 40s and the high 30s. And Jim Lovell and Fred Hayes, the only thing they could put on extra was they had their lunar boots that they would wear on the moon. They had those to put on their feet. Jack Schweikert only had an extra pair of underwear. So that's what he wore. And so they were all three miserable. Of course, Fred Hayes got a urinary tract infection. They all got cold, but he was more affected by the cold, according to what I read, is that once you get cold, you stay cold, and it's very hard to get out of that mode until you get some really good heat about you. So they were kind of miserable the whole time that they were doing it. They were restricted to 6.8 ounces of water a day per person per crewman, and they were hoping that they would get through. But 2 hours before reentry, they did run out of water.
Mm.
But what they found out later is after they got the capsule back, that the water tank, the lines had frozen. They still had water in the tank, but they were never able to get that out.
Mm.
And also, this was the first time that the crew, the astronauts were flying they called wet packs to the moon. That is, they had food with water in it so they could heat it up. And what they were doing was they were also sucking the water out of that to keep them going, because you need water to keep your brain functioning.
Absolutely, absolutely.
Yeah.
I hope you're all enjoying this conversation with Gary Allgire. We got a few more slides to go here as Gary's outlining this the
move on.
details of the
This
tanks.
just shows, let's see, let's go one more. Yeah, this shows the 3 batteries that are in the command modules A, B, and C. C's behind my back. That's why you don't see it. And they used A for 30 minutes, and it
Go back.
reduced.
Go back.
I'm sorry, go forward.
Okay, you'll see the 3 batteries there. These are dedicated strictly for re-entry. They have to be fully charged up, and they're 40 amp batteries. The battery A, during that half hour, they used 50% of the battery, so we're down to 20 amps. Now they have to recoup these 20 amps. Before they've powered down the last fuel cell, or they lost the last fuel cell, they did put a charge on it because the command module has a battery charger in it. It also has a surge tank for oxygen for them to breathe, and they have a 5-gallon water tank in the command module. Okay, and the water is being supplied by the fuel cells because they produce water as a byproduct. And so we had to, let me see, I'm losing my track here, what I was going to talk about. The battery is reduced to 50%. Now, the fuel cell was going to be shut down. Also, what the fuel cell was trying to do was pull oxygen from the surge tank that was in the command module. And they noticed that right away, thankfully, and they isolated that because it was trying to pull oxygen out. So this is the problem that they were witnessing. So when they put that battery on, they were given, Cy Liebernaut got the information he needed and told him, hey, you got to go in the lunar module. And so they had to put the charger back in. So this is in Apollo 10 is when they came up with this idea of flipping these switches and circuit breakers. And what I didn't point out, circuit breakers that we use in these spacecraft, we don't have circuit breakers like you have in your house. You have a circuit breaker on your service panel in your garage or in a room. And for one breaker, you may have your whole room on that breaker. And then you'll have a separate one maybe for your hot water heater if it's electric, or your washing, your dryer you have in a house. We do not use that. We use single point circuit breakers. So each power line that comes off of the bus has got a circuit breaker on it. It's a push-pull. You push it in to engage it and you pull it out to pop it out. So for every wire that comes off that bus has a circuit breaker on it individually, which is different from your house that you would know. So to do this change from using the batteries in the lunar module to charge the batteries in the command module through the charger, what they needed to do is a combination of over 100 switches and circuit breaker combination had to be changed. There's 100 of them.
Over 100 of them.
Yes, and this is what Ed Mitchell had to get that stuff ready to do, and so did Ken Mattingly, and give all that information back up to them.
Interesting.
And this is the quantity of batteries that we had. The lunar module descent stage had 4 batteries. They went to 5 when they went to the extended missions on 15. And the voltage was 29 volts across the board. There was the top capability. There were 400 amp batteries in the 4 of them in the descent module. The lunar module had 2 that were rated at 296 volts, amperage rather, and the command module had the 340s. So if you added up the total voltage that the lunar module had, it came out to 2,190 hours of amp hours that was available for them, which is 9 days. Okay, it was going to be a little longer than that, so that's why they had to power down to 10 amps total. In the lunar module, the only thing they kept running was the environmental control system, the comm system, and the guidance system was the only things that they kept powered up. Everything else was powered down. The command module, everything was powered down. This just shows the location of the surge tank. It's in the vehicle. It's green. It's inside. It's in the lower equipment. Well, it's inside between the two pressure vessel and the heat vessel, and you have your 5-gallon water tank. After this mission, they added another additional 5-gallon flexible tank that was put in behind one of the compartments in the command module. So they ended up having 10 gallons. Now we have to do another mid-course correction because GUIDO, which is the guidance system that at JSC is monitoring the trajectory of the mission. And so they noticed that they're not going to make the critical angle of re-entry, which is 5.5 degrees to 7.5 degrees. So now they're required again to do another burn of the descent engine to get them back properly on that. Now they could not use the guidance system to IMUs because they were powered down. We could just use the RCS engines in the main engine. So this is when they pulled out the old trick that Jim Lovell had learned, using the COAS to look through the lunar. Well, before we get there, I guess we need to talk about during that time frame between the point A. I mean, we came around the moon until then. We have to come up with a configuration for the lithium oxide canisters. And so let's go to the next one real quick here. You'll see the two. The round one is the lunar module lithium oxide container, and then you'll see the square one we have in the Apollo program over there. So now we have to configure those two to match, and this is when they came up with we can go to the next slide.
There you go.
There you go. Where they used some piece of cardboard from one of the procedures, some plastic, and they used duct tape, and they made a little dam over it and to keep it from collapsing. And they would tie that in the exit point. The air comes in through the bottom of the canister. They actually could put two canisters together, so it'd go through two canisters, and then it would come out and through that hose, would hook into the lunar module connection and go through a series and come back out as air into the filtered air into the cabin itself. This shows pictures of the Jack Klausma with the canister right there, and the next one.
No, that'd be Schweikert.
I mean Schweikert, yeah, I'm sorry.
Actual in-flight picture there.
In picture. And again, this is showing it strapped to the wall. And you see right below it is where the canister went for the lunar module.
Marty, it's appropriate. He has a question, Marty, that Dave Stingy's got there.
Yeah, were the CO2 filters all made the same shape on future flights?
No. We call it form fit functional. And the functionality is the lunar module had 2 people on board, 2 crew members for 2 days or 3 days, whereas the command module had 3 people on it for up to 8 days. So the functionality, they were different. Form is because we have to change because there was not the shape of the lunar module and the shape of the command module drove the shape of these canisters, because to make them fit into a lunar module, they had to do that shape that they had.
To store them.
Not to store them, but to actually use them.
Okay.
Okay. Now,
how many they take with them? How often they have to
well,
change
it? They're good for 24 hours. Now they have pairs. They put 2 in the command module. They activate one of them, and they'll run it for 12 hours, and they'll pull it. They'll put another one in its place, and then they'll activate the other one. So they change them out every 12 hours. And what do they do with after the 12 hours with that one? I guess they put it back in there. Now, we stored a bunch of those in our command module. The word that I've heard was for the lunar module, the canisters were stored outside on the lunar module, because they had enough in there, I guess, to go to come off the, when they got into orbit around the Earth, around the moon, and land. They had enough in there to do that, and that was the reason why they didn't go back and get more of their canisters. That's why we had to use the command module canisters.
Okay.
Okay. So now we're going to go back to what happened to it. Okay, we're going to go back to where we got to do this.
Number 12.
Number 12. Actually, it's number 10. We're going to do number 10.
Third mid-course.
Yeah, this is the one where they use the COAS. It's mounted in the lunar module window. You can go ahead. I think the next picture. This is the COAS. It's mounted in the window. It's basically a flashlight. It has a 45-degree mirror glass on the other end of it that reflects the crosshairs onto it, and then they have knobs where they can adjust the crosshairs. So this is what we did in the docking test.
White, is that the white knob there?
I think the white one is it. I'm sure it's electrically powered. Okay, so he would use that. He would look through the glass, which is not shown there, so we don't have it. And this is what he was supposed to look at. He would put the vertical line on the center of the Earth, and the horns are the two ends of where
It's a crescent phase.
Crescent phase. You always get that coming back. I guess you're not coming directly back to the Earth full force on a place. But he put this on there, and so that's what they would do. It took all three astronauts to do this maneuver. Jack Spiker did the timing and tell him when to stop. Fred Hayes did the roll controls, and then Jim Lovell did the pitch, and he was to turn the switch on and off. And they did this for I think a couple of minutes and so many seconds to put them back onto the proper trajectories for re-entry. Now, again, we go along, and guess what happens again? When we get to 11, we have to do it again, which is 1 hour before we're going to see, what was the time? It was 5 days. This is command modulation, separation. Got to get my glasses
Yeah,
off.
3 hours
Yeah,
late.
yeah. That was 3 hours later. This one here, we did this one right here, right before we come to re-entry. They did another one using the same method. And so now they supposedly are set up for the proper trajectory re-entry angle. Now, the first thing they're going to do is they're going to go in and they're going to separate the command module, service module. And this is what they would use. Now, when they went in there, first of all, they had to power up. This is when they went in there. They've been in many times, but this is what was looked on the hatch window. You can see the ice crystals that are on the window. And they have a lot of moisture on the walls, and that's why they were concerned about all the electrical connections and the wiring and the command module, whether they would work or not. And they did, because of what we did in Apollo 1. Let's go there. Okay, what we got to do, before this happens, we're going to separate the service module from the command module. And to do that, we use the RCS engines in the lunar module to do that separation.
So they took the service module, the big cylinder on the back there. They ejected that before they separated from the lunar.
Yeah, so we're flying a real weird configuration.
Yeah.
We got the lunar module and the service and a command module attached to it. This is when they kind of went around.
With the heat shield now exposed for the first time.
It's also exposed for the first time, but it's also the first time that they actually looked at the service module to see the damage that was done. And we'll have some pictures later on. I'll show that. Okay. So after they did that, then the next thing that we're going to do is we got to separate the limb from the command module.
Aquarius, and there's the ladder
yeah.
that they would have walked down, Fredo and Jim.
And Jim Lovell was the last person that came out of the lunar module and went into the command module. So now they're all set up to do this. This is actually the lunar module on 13. They have separated. You can see the docking ring on there. The probe is not there. Maybe this is another one. The probe is, I guess, back in there. Should have been with that, but anyway, we brought it back. And this is a sketch of what they had. And when the panel came off, It damaged one of the four antennas, and at the time they were on narrow beam communication, and it kicked over to wide beam. So they lost about a second and a tenth of a second problem. Also, the vehicle, when that happened, it really moved sideways a little bit, and the guidance system people on the ground saw that, and they also recognized the fact that there was a lot of firing of the RCS engines to bring them back on track. So anyway, this is what they saw. They also saw a smudge that was on the engine bell, which indicated to me that there was a compromise to the tunnel in that panel area. And actually the pressure had gone down through, came out through around the engine heat shield and made a burn mark on the deal. So it was a really good decision wise decision that he decided not to use that engine to put him back, do a U-turn, come back to Earth.
It'd have blown it off.
Yeah, it would have been catastrophic. This is a picture of it. It's hard to see here. You got a question, I think? Oh, it's hard to see here, but I put an arrow on it, but it's not going to show up. But actually, I could see a small separation between one heat shield and the other to verify that, yeah, verily, that's where that came out of, that air came out of. And then I circled the antennas, and then I drew lines to the two fuel cells that you can see.
Those antennas don't look good at all.
Well, only one's bad. They worked. They used them for a little bit, but mostly they used the lunar module's antenna to communicate to Earth. And then the reason I put this picture in is most people don't know this, is when we fly the lunar missions, we paint the heat shield. You see that ring? It's gold.
Yes.
That is actual gold flakes that have been put into a paint and painted on. And it comes to us, it's covered with
heat shields for the engine, heat off the bell that doesn't affect anything behind it there.
And so when it comes to us, it has a white tape over it, and we pull that off as we put the engine bell on. Yeah. But all those have, now if you look at any of them that had flown like Skylab's or Apollo 9 or Apollo 7, they did not have those on there. It was not gold.
Yep.
This is the next one's entry, I think. No, this was another thing. This came from Apollo 8. It's nothing to do with anything, but other than out of the pad, we have to cool the tanks. And to do that, we bring air over from the launch escape, the tower, into the vehicle. And it's an opening about this big, like this. And the requirement is we have to flow 100 pounds a minute through that orifice. At 100 pounds a minute, that goes supersonic. And it's so loud in there, you cannot communicate to anybody. The only way we could communicate was to cup our hands like this, put it over our mouth, go up to the guy's ear, put it up on his ear, and scream like crazy. That's the only way we could talk to people. We reported it to management. They had the safety people came out. I don't know what they did or what they did, or when they were there. They came back and said no problem. And then OSHA said no problem. So what they ended up doing is going to a much later time of turning the air on to cool the tanks after they're fueled. The other part, but the reason why the blanket's there is because that air came across. We have all these mylar blankets, which is basically a metal, and they would start vibrating and vibrating, and they would start breaking apart, and they caused all these little stars that you would see in space if they were out there. And so when we opened up a panel, this thing was just covered with these flakes. So we had to go in there and vacuum it all out for Apollo 8. And the fix was to put this blanket over the top of it. And I've outlined the blanket in red so that you can identify it. But all those missions after Apollo 8 have that on them. Now we're going to re-entry. Now the question was asked, why did it take 6 minutes instead of the 4 minutes? And the reason why that I've heard is that they came in on the very low inside of the 3.5 degree entry angle. So it caused them to come in and stay longer into the plasma. Yeah, so that was the 2 minute extra because they came in at a really shallow angle compared of that critical area.
Of course, that was with design limits of the heat shield.
Yeah, yep.
Okay,
So
great graphic there. This
And
all
it-
happened 55 years ago this
Yeah.
afternoon.
I put this in here because one of the things that Jim Lovell asked, the crew asked before they came back and re-entered, was about the lift over drag, and so why would they be concerned about that? Well, that's how they steer because they have an off-center CG, and they can use the RCS engines to pitch and roll the vehicle, and that would cause the vehicle to go sideways or up and down, or to land as close to the carrier as possible. Now, the reason they asked for that is because they hadn't been eating much, they hadn't been drinking much, and when they do the fecal systems, they store it in a compartment down in that lower area, and he was concerned since they didn't have enough fecal matter produced during the mission that they was offset the CG, and what they did is they took all the cameras that they had there and stuck them down in there. And they asked JSC, was that equivalent to what they should have had? And they said, yes, you do. You're fine. So
4 or 5 hots of blood was equal
Yeah,
to their
yeah.
fecal matter there because they weren't eating and
yeah,
stuff like
yeah,
that.
yeah.
That's good. All right.
And then over here is just to go through reentry. It's a little bit different from what's shown here, but they come in when they come out and hit the atmosphere, they're going at 17,800 or 700 miles. They're going 24 to 25,000 miles.
25,000, yeah.
Miles an hour. When they come into the thicker atmosphere, they're down to 300 miles an hour. And that is when what they'll do is at 25,000 feet, they'll jettison the forward heat shield. And then after the heat shield at 23,000 feet to deploy the drogue chutes. The drogue chutes will slow them from 300 miles to 175 miles an hour. And then they'll open up the pilot chutes to bring out the main chutes. And then they will hit the water at 22 miles an hour or hit 12 Gs. And that's the end of your mission.
12 Gs. So
And it could be 40 Gs depending on wave height. There's the crew.
Happy ending there. Fred Hayes there, Jim Lovell in the bottom, and the late Jack Schweikert, born in Denver. If you've been in the Denver airport, they have a statue of Jack there. 2 of the 3 alive to talk about it.
Jim. I just
really
saw a picture
interesting.
of Jim Lovell. A lady was here in the museum today that sees him on a periodic because her dad's in the same assisted living facility as Jim Lovell. She has, I think, 4 kids or 5 kids, and he loves kids. And she showed me a picture of him having the kids on his lap, and her standing behind her. And it was taken 2 months ago.
Yeah, he's 97,
Yeah.
and I've talked to several people that have visited him. He's 97, but fully brains working. He does not have dementia.
He says
Anything like that.
he loves kids. He says he's very kind to the kids. He loves kids. Every time they come in, he talks to them and he puts them on his lap. So she said he was a very wonderful person.
Born in Cleveland, Ohio, but I think he lived a long time in the Chicago area.
The Chicago area. In fact, he's in Illinois. Is where the assistant living is, outside of Illinois.
And then, of course, if you've ever been to the Cosmosphere in Hutchinson, Kansas, this is the Apollo 13 Command Module Odyssey. We actually have some safety netting from Odyssey in our exhibit here. On a placard signed by all 3 astronauts, and Walt Capron, the launch director of this mission there. I've been there and seen it just like this. Couldn't find my own personal pictures. Shown a time or two me behind the heat shield. The heat shield looks rather eat up, quite frankly.
That's the design. It eats itself away.
Yeah.
Okay.
And but They had the hatch off of it laying there. Not sure, if it's the exact. You mentioned there might be a few pieces and parts not
Well,
there.
there's one thing I have an issue with, and it's just me, is that they have the docking ring on it, and the docking ring would definitely not be there. It's, as you saw in that picture, we left the docking ring with the lunar module, and there was must evidently one spare one around, and somebody decided to go ahead and put it on there. So it's not a true representative of the vehicle as it looked at when it landed in the ocean in the South Pacific. Only one other thing I forgot to point out is this, the Atomic Energy Commission went to NASA and said, hey, you didn't deploy the LSEP on the moon. So the LSEP's still there, and it has a isotope thermonuclear generator on it or something
Yeah.
like that.
Uranium-245.
Yeah. And he says, we want you, when it goes into the South Pacific, to aim it so that the lunar module will hit the deepest part of the South Pacific. And the deepest part is called the Tonga Trench. And then they landed in between Samoa and New Zealand. And they actually landed the lunar module in the trench. And they went back and they did drop sensors to see if there was any radioactivity, and there was none. But
Has anyone photographed it in the trench?
I
with
don't
pieces
know.
and parts of it?
I don't know. Did it
How
really?
did they do that accurately?
That's
with
what I
the-
question. That's what I question. But
Yeah,
that's what
Marty,
that's what
you're
stated.
the lunar module expert. Would they have?
There's no way.
They couldn't remotely control the reaction control
No.
thrusters on the lab.
No, but that's what the story is. That's what's been published.
But it did re-enter the Earth's atmosphere.
yeah,
Well, why
yes.
wouldn't most of it burn up? I
Well,
know most of it did, but
well,
they're talking about
these things are well protected. They're protected, so if there was an
the RTGs. We're talking about,
RTGs
yeah.
are protected. So
radioactive thermal
if
generators.
during launch the Saturn V blew up and it came out and it landed on concrete, it cannot open up. It has to be stay solid.
Very interesting. Yeah, they are very, very safe.
Yeah.
Well, we got a couple things going here. As some questions here, we want to thank Mark Thel, Doug Forrest, Gary Gerald, my daughter Jessie, Carlton Bailey watching, Mitch Rothman, he's recovering from Shuttlefest, Tommy Usiak also, Dean Babcock, Julie Clay watching today. Thank you, Julie, for all your Shuttlefest help. Steve Jokums, Mark Usiak, John FL 142, welcome to the family. Rocket Lady Elizabeth, we talked to her a couple weeks ago in her business, Galactic Medallion Tours. Elena Adhekahara, Dave Stange, Robert Mecklenburg up there in the Netherlands. We Be Good is watching. Bob Mayran, and let's see, we've got
Robert Law, he's
Robert
traveling.
Law in Dundee, Scotland's on his way home. Everyone said this is great. Did you know that the Apollo capsule was probably unstable in subsonic flight after entry? NASA Orion capsule is, and the designs are so similar. Apollo capsule most likely was also unstable in subsonic flight after.
Well, that's what the drogue shoots. They stabilized it when it was coming down.
All right.
So
Well, Mr. Big Mouth there. Hope that he says he hoped they put the cameras in plastic bags. Doug Forrest, really great presentation. Gary, thanks for explaining all this so clearly. And he said, Mr. Big Mouse, of course, with substantiates with Gary there. No, the CO2 filters remain the same. They just modified the CSM, so there's a little chance of the same problem happening again. And so anyway, that we be gone. Yes, we feel your pain when those SSME engines are wasted in the ocean on Artemis 2 after using them over and over on there. So
there's a lot of stuff that we hated to see go, but
well, Gary, thank you. Very simple. This is the definitive of Apollo 13. I've heard about it.
yeah, it is. It
in
is.
there. You had the charts, you had the whole thing on there, and it's worth the time and effort for us to review it here today for you fans of Stay Curious. So, Marty, everything okay over there?
Yeah, everything's okay. And we just set a personal record on number of viewers. We hit 42.
Oh, wow. On an hour and a half show.
Yeah, we've
And
never
there
come
you go,
close to that.
folks. What
Great-
we do here at the American
great
Space
job.
Museum's YouTube channel is unlike anything else. on YouTube. So why in the world aren't you sharing it with your friends? And we are, everybody loved this great discussion and went by fast. We're going to take a break for a couple days. Marty and myself, we will have rerun shows on Friday and Monday. So I can go see family up in Tennessee and Marty enjoy his family here. This is Easter weekend here. So however you enjoy that holiday and a religious holiday, of course, for Christians, and others enjoy the bunny rabbit. So
But
whatever
Mark,
you want to do tickles the heck out of me. So
Mark,
thank you, We Be Good, for just subscribing. Steve Jokums passes on his outstanding, and that's a
Oh,
lot from
okay.
Steve. You got to meet Steve at Shuttlefest, didn't you?
Yes, I did.
Yeah, sure did. Marty?
you get the break. I'm here.
Yeah,
doing
Marty's
the
going to be
rerun.
here and helping out. I get the break. Bags under my eyes are disappearing, but I've been working hard on Shuttlefest 5, and we'll give you some information on that maybe next week about some of our efforts of that. So thank you again, Gary. We're
You're
going to miss
welcome.
you personally,
Yeah.
but we'll bring you back. This is an outstanding docent for events that we have here. He comes twice a week on Tuesdays and Thursdays. And you won't be doing that again until, October or November.
Well, I might sneak back here once in a while. We got to come back in May for some medical stuff. And
Those are called doctor's appointments. So this
Yeah, yeah.
senior citizen
And
doctor appointment.
I got a granddaughter's graduating from college, so we're gonna go.
Well, I mean it when I say I'm so happy that you're my friend.
Okay.
It's really an honor.
Enjoy it.
We share a lot one-on-one. He and Marty both straighten me out a lot because I need to be straightened
Oh
out.
no, you do
on the
good. You
facts
do
there.
excellent. Exactly.
But so everybody, thank you all so much for watching. And we're going to reprise 2 wonderful interviews Marty's going to choose on Friday and Monday. And I promise you, I'll be back here in the seat in our studios of Stay Curious, just 10 miles away from the rocket launch pads at Cape Kennedy and Cape Canaveral. Until then, I'm Mark Marquette saying thank you for watching. And I can't wait to see you again to bridge the space between us.
Good deal. Well, I didn't think it was gonna. I thought at one time I thought it would go that long.